Hello, my name is Leah Cohen. I'm here to interview two of the leading scientists in the study of the pollutant gas SO2. This is Dr. Munoz from Aperture Laboratories. Could you tell us about your research to test the effects of SO2 on the environment?
Yes, of course. In order to test the effects of the toxic gas on the environment, I set up an experiment in which I placed plant, water, animal samples in a sealed bag of sulfur dioxide. I also set up a control group which contained the same specimens but in a sealed bag of outdoor air. This was to contrast the effects of fresh air versus the effects of sulfur dioxide on the environment. In order to synthesize the SO2 used in the experiment, I combined 20 milliliters of HCl with 4 grams of sodium sulfite in a flask. Upon doing this, bubbles formed in the liquid, indicating the gas was created. The gas created traveled through a tube attached to the flask by a stopper and into the test bag with the samples in it.
What exactly was in each bag?
We had a sample of moss in each of the bags to represent plant life, blepharisma to represent animal life, and a sample of distilled water with a universal pH indicator to represent the effects of the unpolluted air versus the SO2 on the fresh water.
So what happened when you subjected the samples to gas? And what happened to the samples in the control group?
We observed the bags for a total of 5 days after setting up the experiment. Over that time, the moss in the SO2 bag went from being a vibrant green with moist soil to a dead yellow with dry dirt. Most of the blepharisma died instantly after being introduced to the SO2 gas. The water went from a pH of 7 to a pH of 4 within minutes, and then decreased to a pH of 3.5 on the third day. In contrast, in the control bag, the moss stayed green and healthy, the blepharisma were alive throughout the experiment, and the water only changed in pH slightly.
So why did the moss wolves and the color change, the blepharisma die, and the water turn acidic?
Even when not forming acid rain, sulfur dioxide is very harmful to life. It's soluble in water, so it reacted with the water in the two well plates in the following reaction. The excess of H+ ions in the solution shows that the acidity of the water in both the distilled water well plate and the well plate containing the blepharisma has increased, as shown by the change in the pH indicator. In the case of the blepharisma, the water in their well plate was exposed to the same conditions as the water well plate, meaning the pH of its water was also very low. Organisms are comfortable in liquids at a pH of about 7, but when the pH starts to drop past that, organisms stronger than the delicate blepharisma start to die, as seen in this chart. If sulfur dioxide can do so much damage in our experiment, think of what else it's capable of. This is the reason I'm trying so hard to inform my fellow humans about the dangers of this pollutant gas. In terms of the moss, sulfur dioxide is able to enter into the leaves of plants. However, moss has no waxy protective cuticle as other plants do, leaving it extremely susceptible to the sulfur dioxide. Sulfur dioxide can cause foliar necrosis or leaf death, in addition to causing aging and color loss in leaves in a short amount of time. With a high concentration of such a toxic gas for the long length of our experiment, you could see that the moss didn't stand a chance. In contrast to this, in the control bag, where they were free from the effects of SO2, there were no drastic changes. This contrast clearly demonstrates why it's so necessary to protect our environment.
Thank you, Dr. Munoz. I'm now going to interview Professor Mimini, an atmospheric scientist.
Go.
So, Professor, where does sulfur dioxide come from?
Because coal naturally contains sulfur, the great majority of SO2 released into the environment comes from the combustion of coal. More specifically, about 75% of the gas comes from coal-fired power plants, while some other industrial sources such as petroleum refineries, cement manufacturing, paper and pulp manufacturing, and metal smelting and processing facilities make up about 20%. Also, locomotives, large ships, and some non-road diesel equipment burn fuel high in sulfur dioxide and release SO2. Although most emissions are caused by humans, volcanic eruptions may also release the gas. However, due to its antimicrobial properties, sulfur dioxide is also utilized as a preservative in foods and an additive in wines, although strictly regulated. In homes, SO2 can be found from tobacco smoke, inadequately vented gas appliances, gas heaters, wood or coal stoves, or automobile exhaust.
So what are those negative effects that you mentioned?
The list of negative health effects sulfur dioxide can have on the human body is astounding. Exposure to SO2 irritates the nose, throat, and lungs, and induces loss of smell, headache, vomiting, fever, and dizziness. Sulfur dioxide can react with other chemicals in the air and form tiny sulfur particles. These particles can gather in the lungs and cause respiratory problems, disease, and premature death.
The people most commonly hurt by sulfur dioxide inhalation are workers in factories that burn coal and people who live near these types of factories, or even volcanologists. Further, asthmatics are extremely susceptible to the effects of very low concentrations of sulfur dioxide, leading to an increased frequency of asthma attacks. Like we discussed with the moss, sulfur dioxide can also damage plants by simply entering through their leaves. On the other hand, acid rain is one of the worst effects of sulfur dioxide, formed when sulfur dioxide is released into the atmosphere. The sulfur dioxide reacts with O2, forming sulfur trioxide. This then reacts with water vapor or liquid water, forming sulfuric acid, which is a signature component to acid rain. Acid rain can be carried into bodies of water, lowering pH and killing aquatic plant and animal life. Also, it can harm forests and trees, killing leaves, damaging bark, and causing them to be more susceptible to overall damage. Acid rain also kills vital microorganisms in the soil that supply nutrients to plants. And how does this SO2 affect the Dallas area where we live?
Sulfur dioxide has many effects on the state of Texas, ranging from causing political outcries and debates to killing pecan trees on Texas farms. The Environmental Protection Agency, or EPA, has cracked down harshly on Texas plans to reduce their annual sulfur dioxide emissions. Politicians quickly denounced the regulations, saying that the subsequent loss of coal-fired generation would drive up electricity prices and lead to job losses. However, the EPA said the rule would prevent up to 5,900 premature deaths and 54,000 asthma attacks a year in Texas. Although there are no volcanoes in Dallas and very few outbreaks of acid rain, it is a large industrial city with many sources of sulfur dioxide. Environmentalists have said that they believe that SO2 pollution from coal-fired power plants is slowly killing vegetation across Texas. In central Texas, pecan growers say thousands of trees have died, and after consulting experts, the growers believe in nearby power plants, sulfur dioxide emissions are to blame. As the EPA pointed out, there are thousands of deaths, asthma attacks, and respiratory diseases developed in Texas every year due to this pollutant gas. Here's a chart of Dallas's sulfur dioxide emissions in 2008. Thus, it is clear that the effect that the sulfur dioxide has on our own community here in Dallas and Texas is strong, and we must do what we can to reduce it.
It is a shame that there are people in the world today that still do not believe in the pejorative effects of sulfur dioxide. To demonstrate its effects up close, we wanted to set up a small-scale experiment to show even more clearly the damage sulfur dioxide can do. Our experiment showed that every ingredient exposed to the unpolluted air in the control bag remained healthy, while those in the SO2 bag suffered. This parallels the terrible occurrences that sulfur dioxide causes in our own world. Even in very small amounts, sulfur dioxide can cause many different health problems, including respiratory ailments and even premature death. It can also severely damage plant life, as shown by our moss in the trees in Texas farms. Furthermore, sulfur dioxide is a leading cause of the extremely dangerous acid rain. As a citizen of a city such as Dallas, this information is important to you. However, the government is trying to protect you from this dangerous gas. Through the Clean Air Act, the government has been improving air quality by enforcing regulations on gas, cleaning up air pollutants, and judging air quality against accepted safe standards. Due to these efforts, the national average of sulfur dioxide concentration has decreased by 83% in 30 years. The EPA also works to reduce instances of acid rain and otherwise alleviate pollution. On the other hand, here are things you can do to reduce your own exposure to sulfur dioxide. First, there is no specific method to reduce the absorption of sulfur dioxide, and you should see your doctor if you come into contact with it. Therefore, avoid it at all costs by avoiding areas by power plants and other sources. In your own home, it is important to make sure to regularly check your appliances and never burn coal for heating or other purposes. At the end of the day, if you ever hear a politician ranting about how the productivity of huge power plants is more important than your and your family's safety, remember this PSA and remember that you have the right to clean air, no matter what the cost is to factories and the pockets of the millionaires who own them.